In this lesson, we're going to be talking about similar figures and missing information. And so just as a reminder of what similar means that you have two figures that are the same shape, but are a different size. And in order for two figures to be similar, you must have corresponding angles that are congruent, which means equal. And you must have corresponding sides that are in proportion with each other. And we talked about that in the last lesson. So if you need to review that, feel free to go back and listen to that. Now, before we jump into our lesson today, we need to do a little bit of a review on proportions and how to solve them. We did this a couple units ago, and it should be familiar to you. But this right here is a proportion. 2/5 equals x over 10. And our goal is to find and solve for the variable x. And there's a very systematic way to approach this type of problem. And we're going to be using these things called the cross products. Remember talking about the cross products? We're going to multiply the two pieces that are diagonal from each other. So I'm going to multiply 5 times x, and I'm going to set that equal to 2 times 10. And those are my cross products. Once I do that, I have an equation that I'm going to go ahead and solve for x. So I'm going to go ahead and write 5x, and I'm going to simplify 2 times 10, and that'll give me 20. And then since I'm multiplying the 5 by the x, I'm going to divide both sides by 5. And my 5's cancel out, and I'm left with x is equal to 20 divided by 5 is 4. So what that means is that x right there, that missing information, is a 4. That would make the two ratios equal in the proportion. Okay, we need that as we move forward here today. And there's one other piece of information here that you're going to need, and we'll talk about it a little later, but it's good to know now that the sum of the interior angles of a quadrilateral measure to 360 degrees. And we'll take note of that in just a moment. Okay, let's go ahead and first begin by looking at some figures. And it says the figures below are similar. So if you want to, you can even do this little symbol here. That means similar. They're the same shape, but a different size. And it says determine the missing side lengths by setting up our proportion and solving. So the first thing we want to do here is identify the two figures and kind of give them a name. You can say large and small. You can say figure 1 and figure 2. It truly doesn't matter as long as you name them. So I'll go ahead, and it looks like this one's actually the larger one and this one's the smaller one to me. So I'm going to label it large and small, and I'm going to go ahead and write that down here. So large and small. And it doesn't matter whether you write large on the bottom or top, as long as you stay consistent. And I'll show you what I mean. Okay. The first thing we want to look at are corresponding side lengths. So locate your variable. The variable is what you're searching for. So I locate my side length x. Notice how it's on the large triangle. So I'm going to write that in the little right above, right in the first ratio, right next to large. That side length corresponds to this side length on my other triangle. Now it's rotated, so if you need to rotate it and rewrite it so that it looks like the large triangle, you're more than welcome to. Okay, so since it's corresponding to the 12 on the small triangle, I'm going to put the 12 at the bottom where I put a small. Everything has to be lined up perfectly. Okay, the second part is I need to find two other side lengths that have numbers attached to them. So if you look at 36, this side length here, do you see that side length? Notice how it corresponds to this side length here, but it doesn't have a measurement. So I actually can't use those two corresponding side lengths because I don't have the numbers that I need. So let's go ahead and grab some other numbers. How about this one? 20. 20 corresponds to 4. So 20 is on my large triangle, so I'm going to write that in the top. And 4 is on my small triangle, so I'm going to write that on the bottom. Once I've set up my proportion, all I do from here is solve it out. So I'm going to go ahead and solve using my cross products. So that's going to be 4 times x equals 12 times 20. And you can absolutely use your Desmos calculator to calculate these large numbers. So 4x is going to be equal to 240. And since 4 is being multiplied by x, I'm going to do the opposite operation, and I'm going to divide both sides by 4. My 4's will cancel out, and I'm left with x is equal to 60. And so what that means is that missing value over here, that missing side length, that length of that segment is 60. All right, let's try number 2. Okay, number 2. Again, let's go ahead and begin by giving them a name. You can call them figure 1, figure 2. Let's go ahead and do that this time. I'm going to call this figure 1 and figure 2. So just to kind of change it up a little bit. Figure 1 and figure 2. It doesn't matter the names that you give them as long as you're consistent throughout the problem. Okay, let's find 2 corresponding side lengths. It looks like here's the one with my variable, x, and it's on figure 1. And it corresponds to 9 on figure 2. Okay, and the other corresponding ones is going to be 7.5, which is on figure 1, and 15, which is on figure 2. Okay, now that I've got my proportion, let's go ahead and use my cross products to solve for x. So here I have 15 times x equals 7.5 times 9. And again, use your Desmos calculator to calculate that out. 7.5 times 9 is going to be 67.5. I'm going to divide both sides by 15. And x will end up being 4.5. And, you always want to double check and just kind of ask yourself, does my answer make sense? So if you kind of replace this missing side length with 4.5, does it make sense? And it does make sense because the other side length is longer and it's 7.5. So, for example, if you got an answer like 25, that it wouldn't make sense. So always ask yourself, does my answer make sense? Okay, now that we've done 2 kind of basic problems, let's go ahead and apply this concept. So look at this next one. It says here, find the height of the tree, which is x. So here we have 2 triangles. Do you see the triangles? Here is one triangle, and here is the other triangle. Okay? And what we're doing in this problem is the tree is casting a shadow on the ground, and that tree's shadow is 25 feet. And then we have this little person off to the right. That person is 6 foot tall, and he's casting a shadow that's 10 foot tall. And of course, it all depends on where the sun is located at that point of the day. But our goal is to use this information to determine the height of the tree, because we can't necessarily take a tape measure and figure out how high the tree is. So let's use proportions to find the missing information. Okay, so let's name the figures. So why don't we do, you wanted to call this, we'll call this figure 1. And we'll call this over here, we'll call it figure 2. You see that? Okay, so figure 1, put in my word ratio, and figure 2. Okay, figure 1. Okay, let's look at the variable. This side length right here is my variable. It's the height of the tree. Let's figure that out. So we're going to put an x right there. That corresponds to the height of my person on figure 2, which is 6. I also can see that the shadow that the tree casts, that's going to be in figure 1. that corresponds to the shadow of the person, which is 10. Okay, now that we have our our proportion, let's go ahead and solve it. So using our cross products, we're going to set up 10 times x equals 6 times 25. So 10x equals 150. I'm going to divide both sides by 10. And x equals 15. And this is more specific in this problem. This is going to be 15 feet. And what that means is the tree itself is 15 feet high. So we really use that same concept that we did above. We just applied it to a more practical problem. Okay, let's try another practical problem. So this one, we're looking at two triangles, and these ones are a little tricky. So let's look at the first one here. Triangle BCD. Well, that's going to look like this. B to C to D. This is the first triangle. And then let's look at the second triangle. The second triangle is ACE. So that's going to be A to C to E. So there are two triangles embedded in each other. So we have the small and then the large. And again, if you want to rewrite these, you're more than welcome to kind of redraw them on the side of your picture, but I'm not going to do that today. Okay, so it looks like we have a small and a large triangle. Do you see those? So let's do the small triangle and the large triangle. All right. And it looks like the small side length, you can see that the small triangle right here has a side length of x. That's what we're looking for. So I'm going to put an x there. And that's going to correspond to, now careful here, look, this side length here on the triangle is 18. So it's going to correspond to the large side length of 18. Okay. And then let's find two other measurements that we could use. How about this one? 6 corresponds to 12. So 6 on the small triangle and 12 on the large triangle. Now that we have the information, let's go ahead and solve it. So use our cross products. We have 12x is equal to 18 times 6. So 12x is equal to 108. And I'm going to divide both sides by 12. X is equal to 9. So what that means is this little measure right here on my small triangle is 9. Okay, let's move on to looking at similar statements and proportions. We're going to use the same skills we just did, and we're going to determine which proportion is demonstrating similarity. So basically, using your triangles here, you want to figure out which proportion is representing these images. So let's look at letter A. 42 over 7. Well, let's look at this. 42 over 7. Those look good. But what about n over 9? The long to the small. So this is my large one to my small. So we went from 42 to 7, so large to small. And then we went from n to 9, large to small, and they were corresponding. So this is actually our answer. But let me show you why B, C, and D are not our answers. So let me kind of erase this and go back. So letter B, let's look. 7 over 42. Well, 7 to 42, so we're going from small to large. And then 3 over n. 3 over n. Look at 3 over n. Those are not corresponding side lengths, so that cannot be our answer there. What about C? We have 18 over n, so 18 over n, and we're only looking at the large triangle here. And then 7 over 9. So you can see that those side lengths that we use there are not corresponding. So that can't be our answer either. And then 9 over 3. So 9 over 3. and n over 42. Again, not the same side lengths, can't be the same. And then we'll look at another one, number 6. This time we're looking at the proportions of the side lengths. So look at number 6 here. EF over AC. So we have EF to AC. Are those two corresponding? No. So we can automatically cross it off. How about B? We have CA to FD. Oh, those look good. And then what about BC to DE? Uh-oh, those don't work. All right, what about letter C? We have AC to DE. Not corresponding, doesn't work. How about D? AB to DE, those look good. And then AC to DF, those are proportional. All right, the last thing we're going to look at in this lesson is determining the missing angle measure in a quadrilateral. And this is where that piece of information from the top of your notes kind of comes into play. The sum of the interior angles of a quadrilateral is 360 degrees. So just like a triangle, the interior angles of a triangle all add up to 180. When you have a quadrilateral, which is 4 sides, your interior angles are going to add up to 360. So we want to figure out what is the missing value. So what we're going to do first is we're going to add up all of the other numbers inside of the quadrilateral. So we're going to take 128 plus 42 plus 90. And you can put this right into your Desmos calculator. And that's going to equal 260 degrees. Remember, these are degree measures. And to find that missing angle, we're going to take our sum of 360 and we're going to subtract 260. And that's going to give us that remaining angle measure, which is 100 degrees. See how we did that? Let's do another one, number 8. The first thing we do is locate the angle that we are looking for, and we're going to add up all of the other angles that are represented. So 150 degrees, plus 62 degrees, plus 54 degrees, and that's going to equal 266 degrees. I'm going to take that number and I'm going to subtract it from the total that we could have is 360. And that's going to give us a remainder of 94 degrees. So that angle measure that we're missing there is 94 degrees. All right, and that brings us to the end of our lesson on similar figures and missing information.